In the first video on arrays, we talked about how to create arrays of different types, allocate their memory, and then put some values into them. I also started talking about some of the techniques for using arrays, and we're going to continue that here. To recap briefly, we saw before that the first step is to declare an array. Then you have to allocate memory for it so the computer has a place to put the information in the array. And then finally you fill in the values. We saw one set of examples for declaring arrays of integers, floats, or booleans, but you can make arrays out of anything you like, colors, or characters, or any data type you like. Once you've declared an array, you then have to allocate the memory for it. This is an extra step you don't have to take for a simple variable like a float or an int. But because we're creating lists, we have to take this extra step where we tell processing to actually create enough memory to hold a certain number of elements for the list. In this case, 3 or 130 or 12 elements. We only have to do this once per array. Once that's been done, we can then start filling in the values by referring to the individual entries of the array. At the end of the last video, we took a look at a particular array of 6 integers, and we talked about how these are numbered starting with 0. So if the array is named radius, then each of the entries is radius open bracket 0 close bracket, radius open bracket 1 close bracket, and so on, all the way up to radius open bracket 5 close bracket. This is admittedly a little quirky and a little weird because normally we don't start counting things from 0. But we do start counting arrays at 0, and we'll see that that's actually pretty useful later on when we start writing for loops to walk through the elements of the array. For this array, we can put integers into each box. So the first entry, radius open square bracket 0 close square bracket, has the value 13. The second entry, which is radius open bracket 1 close bracket, has the value 7, and so on. Let's talk a little bit more about what's going on here, and then we'll take a closer look at step 3 from the previous slide where we fill in the values of the array. You may have noticed it takes a lot of words to refer to one of these things. The big example at the bottom I've been referring to as radius open square bracket I close square bracket. That's such a drag to say that almost no one says that. What we say is radius sub I. Sub is short for subscript. That's because all of this notation comes to us from mathematics. And when you write one of these things mathematically, you use a subscript, which is just a smaller letter that's placed a little bit below the letters to its left. So if you were writing this mathematically, you would say radius sub 0, radius sub 1, radius sub 2. And for convenience, that's how we say it in programming as well. So the box that holds the 15 ball is radius sub 4. The number that goes in the square brackets is often called the index. So the box that holds the 15 ball, we would say is radius sub 4. Or we might say the 15 ball is at index 4. Now here's the tricky thing, and this is, again, another result of what comes from starting with 0. Index 4 is the 5th entry, right? Counting from the left, by normal counting, we have 1, 2, 3, 4, 5, so the 15 ball is in the 5th slot. But that's not how we're numbering them. It's in the 5th slot, but it's at index 4. And so when you're talking to people or you're even thinking about your program for yourself, you really want to get in the habit of always thinking about the index, not the counting number. You don't want to say that the box with the 15 in it is the 5th box. You always want to say that's the 4th box, and so the one all the way on the left is the 0th box. Otherwise, you're going to start counting with 1 sometimes and start counting with 0 other times, and you're going to get confused. Or you're going to talk to someone else and they're going to get confused. As I said before, it's just one of those things. And this is one of those things that you will definitely get used to much more quickly than you might think, as long as you always keep it in mind. So how can we use this to fill in the values? Let's take a look. One way is to just stick the values in. So if xpos has 3 entries, I can just stick numbers into them. xpos sub 0 equals 1, xpos sub 1 equals 3, and xpos sub 2 equals 9. And now I've filled in all 3 entries in xpos, 0, 1, and 2. You might remember that our radius array has 130 values. So how are we going to fill that in? Almost always, you're going to use a loop. So here I have a for loop. It starts at 0, and it keeps going as long as I is less than 130. It goes up by 1, and each time through, I stick some number into radius sub I. In this case, I'm just putting in 2 times I. So if I was drawing circles, the circles would get bigger and bigger and bigger as we worked our way into radius. Inside the loop, I will have values from 0 to 129, which is exactly what we want for something that's 130 units long. Now, I said before that the arrays can get shorter and longer over time. So if you're writing a loop, how do you know what number to type? I mean, suppose we make radius twice as long. Now that upper limit has to be 260, it sure would be nice if we could find out from processing how long the array is at the current moment. And then we can just run through all the entries, whatever its length. And there's a way of doing that. Here's an example of that for the visible array, which is an array of booleans. So you can see in the body of the loop, I just set visible sub I to be true. So I'm going to set all the entries to true. But the interesting thing is the test in the loop. So the for loop begins by declaring an integer I, setting it to 0. And the test is visible.length. The dot here is the exact same key that we would use if we were typing a number like 3.7, but we're not using the dot as part of a number. It's being used in a different way. It's almost, think of it like a magnifying glass. Inside of the array named visible are 2 things. One is a list of booleans. And I think in this case we had 8 of them. So there's a list of 8 booleans inside of visible. There's also a variable that processing maintains for you behind the scenes named length inside of visible. And if you make visible bigger, length gets larger. If you make visible smaller, length gets smaller. Processing is always managing that variable for you. And it belongs to visible. So there's a visible.length, radius.length, xpos.length. And by sticking dot length at the end of any array, you get back the length of that array, and processing manages that for you. So this final example is really the kind of loop you see more often than any other. The variable I goes from 0 to the length of the array, and we just handle every single entry in the array, one after the other. It turns out if you know all the values that should go into your array at the very beginning, there is a shortcut. The shortcut only works when you declare the array for the first time. And you can roll all 3 operations, declare, allocate, and assign, all into one step. And it looks like this. This is a combination of all 3 steps. On the left, we have int bracket bracket xpos. Well, that we've seen before. That says, I'm creating a variable named xpos. It is an array of integers. On the right-hand side, between curly braces, we have the initial values for xpos separated by commas. In this case, processing is going to count them up for us automatically. When processing sees the statement, it sees the left-hand side and it says, oh, it's an array of integers. Its name is xpos. It looks at the right-hand side and says, oh, there's an open curly brace. You're about to give me the initial values for this array. It says that there are 3, 4, and 5, and it's smart enough to count them up, and it says there are 3 of them. And now it's even smart enough to say, hey, wait a second, this is an array of integers, so you must need enough memory for these 3 integers. I'll go make it for you. So it goes off, it does a new int sub 3, it does that for you, it creates enough memory, it sticks that into xpos, and then it sticks these numbers into xpos. So everything happens right away. And this creates the array, allocates the memory, and sticks the values in it. It's really nice, but you can only use this when you declare the array. If later on your program is running and you say, oh, I want to change xpos to be 5, 6, 7, you can't use this construction. Either you assign them manually or you write a loop or you do something else. Now you can do this for any kind of array. So here's our big radius array, which I think had 130 or 300 or something entries. Well, here they are. They're just floating point numbers separated by commas. And this can go on for line after line after line after line, and processing won't care. It'll count them all up, create the array, fill them all in for you. We can do this for any kind of array. So here's our Boolean array named visible, and I'm sticking in the 8 values that I want visible to start with. True, false, whatever. Just the values that can go into that array separated by commas. We've seen a lot of new syntax for arrays, where these square brackets keep popping up. In part 3, we'll recap what we've seen.